In the last part of our video on amine synthesis, we talked about several pathways to create an amine. But in this part 2 video, we'll be talking about reactions involving aromatic amines, aka anilines. So this is a very common synthetic pathways to get to an aniline. Is you start with benzene, add nitro using HNO3 and H2SO4, and then use reduction as mentioned here. So you could use this, or you could use this for nitros. You reduce it and get your aniline. But on the exam, they might give you a variant. They will give you toluene. And to get to your aniline, you would use side chain oxidation, turn this into COOH, and follow this pathway. So to get to toluene into COOH, you would use side chain oxidation, potassium permanganate in base, in heat, followed by acid. Okay, so that's how you make an aniline. However, anilines have a very special property. They are really strong ortho para directors. That means if you want to add a bromide on here, instead of getting a mono-substituted product, you would actually get a tri-substituted product, which is good if that's what you want to do. But if you only want a mono-substituted product, you will need to go through this other pathway to get to a mono-substituted product. And that is firstly by reacting some acyl chloride or some acetic anhydride, but the thing is they both have leaving groups, which is a key here. And that will turn your product into something that looks like this. So instead of aniline, now we get this. Okay, and then we can remove. Okay, and then during this step, this is still an ortho para director. And it is while you're in this phase that you want to add your bromide or whatever. And once you add that, you can convert it back into an aniline. By using some acid followed by base. Okay. Oh, I should write that in pink. In base. Okay, so that will get you a mono-substituted aniline. Now, something really important is when you're adding things onto an aniline, maybe you want to substitute that aniline for a halide on the same position. So something that comes in really often is the diazonium ion salt. So this is a triple bond, and it does have one positive charge on one of the nitrogens. This is super useful, and it can be synthesized using acid combined with NaNO2, but this time we use cold temperature. Be sure to mention that on the exam. So this is super useful because it's a super good leaving group that can undergo substitution with other functional groups. Okay, so we can replace N2 with, well, if you replace N2, you're just replacing the aniline in that case, in the long run. So we can turn this into the halogens, Bri. So F is a little special. You can convert it into cyanide, an alcohol, or we can give the appearance of removing this aniline totally by replacing it with H. So the reagents for this, the first one is copper, and this can be copper chloride, copper bromide, or copper cyanide in heat. As for iodines, Actually, let's do fluorides. Fluorides are HbF4, also in heat, but for iodides, it is Ki, but at room temperature. Okay. And then for alcohols, we would use more copper, copper 2O, copper 2 ion, and the OH source, which is water. That'll get you alcohol replaced with diazonium salt, which used to be the aniline. And to remove the aniline by replacing it with H, you would use hypophosphorus acid in water. So these are the major synthetic strategies of aromatic amines, the anilines. So recap, to make an aromatic aniline, you'll go with this pathway. To add tri-substituted or mono-substituted things on the aniline, you consider these pathways. And to replace the aniline by substituting it with another functional group, you consider this pathway, being sure to include that diazonium salt, which is very important. So I hope this video was helpful. If it is, make sure to check out part 1, as well as leave a like and hit subscribe.